Have you ever heard of supercomputers? Yes? Do you think there are many supercomputers in Nepal? Just one? Do you know where it is? Kathmandu University? So there are multiple supercomputers in Nepal. So my presentation will be on supercomputing in Nepal and with respect to Ubuntu. So who am I? So I am Aatiz Ghimire. So I typically work on supercomputing systems, also known as high-performance computers. I also teach, and I also consult few governmental projects. So how many of you remember this? It's a past year event. This is Kathmandu. Do you see the disaster here? This is last year flood, Nepal flood, September 2024. Do you know how many people were killed? How many fatalities are there? There are 250 fatalities, 18 missing persons, and more than $12 billion of losses. Do you know we have already predicted this? We have already predicted this will happen. How? Do you know how? We have predicted a day early. We have predicted day early. You can look at the date. It was a day early. We advise and issue warning to all government agencies to prepare for a disaster. And the SPC system or supercomputer predicted it. Not only one system, but two systems predicted simultaneously. So technically we saved thousands of people because the government agencies were ready in terms of warning. So typically SPC system predict things like this. They simulate the environment, they simulate weather, they compute molecules, they compute atoms, they work on AI models. This SPC system predicted the flash flood. This system owned by the government of Nepal, specifically Department of Hydrology and Meteorology. It typically predicts 3-day weathers ahead. And this is one of the most powerful computers here in Nepal. So it typically runs on CentOS system, and it can predict 3 days ahead weather. So before this, there were a few other systems. Small scale computing has been happened. So they were all powered by Linux systems, typically on Ubuntu Linux systems. So if you don't know more about SPC in Nepal, so I want to take you back to the history. So we did start the SPC journey from weather forecasting in Nepal. It was initially started by ICI mode. So ICI mode had a 8-node cluster. So it predicted the weather inside the Kathmandu for the Kathmandu airport, international airport, and guided the planes for landing. It provided the detailed weather for the pilots for landing and takeoff. So it was in 2015. Then in 2018, we get it donated by Sun for our first larger supercomputing platform. It was initially started from Kathmandu University. It contains more than 200 nodes. And this was first time public officially recognized the supercomputing system, the need of supercomputing system. And this node is non-operational now. So we do not operate this supercomputing because we don't have, I think Kathmandu University doesn't have that much kind of fund to operate this system. Moving on, in 2020, government of Nepal purchased a 23-node cluster in which the flash flood was predicted. I typically consult on this cluster system. I manage their workload, and this predicts the extreme weather events here in Nepal. So some of you have seen the weather is a bit odd in here at late August. Should not be happen. So this typical type of system numerically calculates the weather simulations and predict the weather in coming days. So there is also another cluster or high performance computer, also known as supercomputers for general public. There is one in Tribhuvan University. So Tribhuvan University founded its high performance computing lab, also known as Supercomputing Center, in 2022. So this both system from government of Nepal and supercomputer from Tribhuvan University, both are operational. So typically, we do have computers. We do have a large scale computers. And we typically work on the things that general public does not know. There are so much load of calculation and scientific simulation happening in Nepal that typically general public does not feel. Sorry. Okay. So why do I love Ubuntu in high performance system? So typically you see that all four supercomputers were initially installed on Red Hat. So do you know about Red Hat? Yes. So all the top 95% computers, supercomputers are installed, which main OS is on Red Hat system. But I love Ubuntu because to operate an Red Hat system and to manage the supercomputing system is too much hard job. And Ubuntu provides a cost-effective alternative because it's open source. We have to pay $599 per node for Red Hat. So Ubuntu provides an open source and free cost-effective solution for country like us. And it also supports wider driver. So generally in TUHPC, also known as Tribhuvan University Supercomputing Center, we work on AI workloads and large language models. Do you know we work on that? So in coming 3 months, I think we will launch our fine-tuned model, Nepali large language model. So I'm the lead researcher for that. I'm implementing the whole system from scratch. So it may take time more than 3 months. But by December, you will see there will be a Nepali large language model. So I have also taken my survey on the users of HPC, especially on TU HPC systems. So major of the users typically use Linux or Ubuntu on their systems. So you can see that 81% of our users use Ubuntu or Linux. So they also prefer an Ubuntu or Linux system for their academic use. It may be calculating large numbers or running scientific loads or AI workloads or large language models. We work on multiple domains. So all of them prefer an Ubuntu or Linux system. So typically our users are moreover postgraduate students or PhD scholars. So they are typical masters or PhD students. So many of you are, I think, currently under the bachelor's degree or near the graduate program. So you don't know typically about these computers. So majority of our users are generally postgraduate or master's or PhD level students. So they after sorting years, after entering into the graduate programs, they switch to Ubuntu. So we work on multiple domains. I have already told you about this. We work on bioinformatics, we work on molecular dynamics, we work on material or quantum chemistry, we work on computational fluid dynamics, we work on weather, we work on deep learning AI models, and we work on GIS and many things. So these are the peoples that work on. Majorly we work on material and quantum chemistry domain and then on AI workloads. So let's see what are they working on TUHPC system. So typically to log in on a TUHPC, we need to access into the system. So assets, This might be blurred. Screen okay? Okay. So it's one of my problem for as an administrator. So when you work on a Red Hat system, I need to test on a Red Hat variant. So I have to forcefully install my laptop OS to Red Hat variant. So I'm sorry for that. I may not be going to jail for this. So this is our TUHPC system. So typically users are more of a sleeping right now. But if I want to check who are working and what projects they are working, I need to add SQ, and these are the projects they are working. So moreover, if you see, there are I think more than 30 simulations running on, probably on molecular dynamics and quantum chemistry. There is no AI workload right now. So this, if you see here, so typically, what do you think, how much the simulation runs for how many days or hours? So can any guesses? So we have a highest record of 205 days. So if you see here time, so if I select this simulation by MCR Joes, it run for 12 days, 22 hours. On a large scale computing platform, it's just a nightmare. So typically simulations run for a longer days. So working on a large scale project is quite difficult job for us. So these computers work on different large scale domain projects. Okay. So I will be using this computer for developing large language model, Nepal language model. So if you can, I can show that the number of nodes they are connected, and we do have 1 or 2 GPU in the system. We don't have that much GPUs in our system. So let's move on. So on a government level, especially on the Department of Hydrology and Meteorology, I've already told you that we do simulations on weather. So this is a typical output of weather simulation. It was done, I think, on August 4, 3 weeks before, and it predicted and worked on 3 days system. So we are moving away from August 4, we are predicting to August 7 weather. So the advisory government gets is from this system. So this system is also not on Ubuntu. It's on Red Hat, but the major component of this system, such as we need to process the data, we need to collect the weather data, we need to find the wind speed, we need to calculate the precipitation, we need a data logger for precipitation. The other components of the system are on Ubuntu. Similarly, this image shows that this is a total precipitation on the system. It's predicting the system, and this will be the maximum temperature for coming days. Yeah. So on the left hand side, right hand side, I think it's on my right. So on the right hand side, you can see this is the internal system. So from large scale simulation, it generally converts into an image, and from that image pattern, we typically suggest you this will happen and that will happen. Do not travel, or this area will get more rainfall, or there will be an extreme drought. Okay. So let's see live. So I cannot access the main cluster because there is more layer of security, and I cannot access from here publicly. So I can show the public images that can be shown. So this is our system. The system WRF, Weather Research and Forecasting, and WFDA, Weather Research and Forecasting Data Assimilation, predicts up to September 3. Today is August 30. I think it typically predicts up to September 3. So this is the precipitation that will happen in coming weeks, coming days. Yeah. And this will be the temperature. I need to play it. The temperature will be changes like this in coming days, in 3 weeks time, in 3 days time. The wind will be flowing like this. It's all scientific computation. So moving on. So why do we think that we need some supercomputing system? So you have got a few answers. We need to predict our weather. We need to do AI work on AI resource. We need to do works on bioinformatics. And typically, on a survey I took a few weeks back, it showed that we all need basic training from HPC and doing jobs and know about parallel computing. They all need training on a Linux system. So on a case study, I run a case study and compared both of the system on a Red Hat and on a Ubuntu. So on Tribhuvan University, this is the system architect of Tribhuvan University. So typically we log in through via a router. It's connected to an IP, and it connects to an head node. So all the workloads are scheduled via the head nodes, and it has a shared storage device. And these are the computing nodes which are connected by a switch. So any job we have will be given on this head node, and the compute node will away and compute the calculation or simulations. So for a typical deep learning workloads, if I want to train on a TU HPC system, I have to do many things manually. So I will show you. So I'll show a simple example of how to do train an AI model or large language model on a HPC system. So if you go here, this is an head node. I have already shown you how to log in it. So this is an head node, and you need to pull the code here. So I have already pulled the code. So you can see there is an TU-DL demo. So I log in into that. I'll go into that TU-DL demo. So check. I need to make a script for each and everything. I have to manually code the things. So I have to train. Suppose I want to train a basic MNIST data set. So I have to manually write the code using, or I can manually write the code here on a terminal, or pull it from GitHub or anywhere. I need to manually give the scheduling job. So I have to write the code for it. C script. So scheduling is typically managed by Slum. If you never have heard about Slum, it's typically about scheduling the jobs on a cluster. So where was I? CD Slum. So if I need to train on a single GPU, I need to manually tell it. Train on a single, let's try on single. So typically a SOM script looks like this. I need to manually give the things. I need a GPU node. I need 8 CPUs. I need 32 G of memory. I need to train it for 1 hour. I need output here and error here. And I have to also manually create an environment. So I typically load the environment here, create a virtual environment, and I also have to manually load the drivers. And I have to also install the requirements manually. Then it's typically look like this. On the contrary, large language models will be also trained like this on a TU HPC. So to access the node or to get a node on a computing system, we need a command srun -- partition. So which partition do I need? So these nodes are typically managed for different domains. So for AI workloads, we typically work on GPU. So my partition will be partition will be GPU, and if I need to log in into that node, I need to add an bin and bash. So bin bash. So do you see that my head node, my computer name has been changed? It's converted into SPC into GPU. So if I check, I can run anything here. So what do I check? I check where is my GPU. So I check there is a GPU. So I cannot do much here. Now I need to go back, and for the scheduling tasks, I need to submit my job that I have written in that train multi.sh file. So I need to sbatch and slum file, slur, work ls, okay, sbatch and dl train single. I need to push it. It will submit the job. Okay, it will submit the job. It's my job ID is 807. So I will look if the job is running. It's running. I think there is some few errors. Oh, there is a problem in the script. So I have to manually check it. So this is too much of hard work in a TUSPC system. Now let me show you up on how Ubuntu will help me in scaling the AI workloads. So you have known that the AI workloads ran as a single script on the slum. So I have to manually prepare the data. Then I have to manually write the script to train, and I have to manually write script for validation and manually write another script for deployment. It's too much hard work on a Red Hat system. So solution will be an Ubuntu system. So if you've known about charmed Ubuntu, have you ever heard about charmed Ubuntu? So it's a cluster orchestration maintained by Canonical. I think Canonical people know better than me. So it typically works on a cluster system. I think it will replace the Red Hat based supercomputing system, and working on here, it's too much easy. So there is another system that typically is worked by the Hydrology department that uses the Ubuntu system. Okay, I need to log in into that. So it will be logged in by a wave interface. I think internet is slow here. Error? We cannot reset from here. So this is an Ubuntu system. It is typically used by the student from Central Department of Hydrology and Meteorology for their simulations. So I have installed an charmed Kubernetes or charmed kubeflow. So it works on a cluster orchestration. It's typically like an supercomputing system, but on Ubuntu's for the supercomputing systems. So it works on a Juju-based system. So there is a session. If you want to know more about charmed Spark or charmed kubeflow, I think there will be a session given by Biswas Takal. I think tomorrow. So to watch my cluster, so I need to Juju status dash s watch 5 seconds. Okay. So here is all my clusters are running on a Ubuntu based system. So this is my IP. This is my other things. The installation process is too easy. It can be done under 15 to 20 lines of commands. So I'll go on the another one. So another one, this cluster is on private network, so I need to export this on internet. So I need to log in again. So I need to check the IP. So where was my script to check the IP? Oh, yeah, it is. So I need to check the IP and I need to expose it on the internet. So that's my IP. I will expose it on the internet. 140.43. Okay. It will be exposed on internet. So typically we do not expose anything on internet. So this is a cluster node. To do an AI workload, this is GUI based. All of the GUI based, we can fine tune, train, data ingestion, anything on this system. So Qflow is typically a machine learning operation platform. It provides end-to-end pipeline. So to do a work here, instead of a TUSPC, you have to write a lot of script and manually do all the things. So here we can manually create the notebooks. Have you worked on Jupyter notebooks? Yes. So I have to typically create a notebook here and select the Jupyter notebook. I have to add how many number of CPUs do I need to? 20? And how many RAM? 200? Okay, 200 maybe too big. 40 GB RAM. But I don't have a GPU on this system, so it's okay. GPU, I don't have GPU here, so I do not select GPU. Value of notebook. So let it be Nepali LLM. Okay. It typically takes a few minutes to go up and running. I've already tested it. Okay, that might be on your. So I will connect on an older system. So if I click on connect, and it will give me an interface such as Colab. It's a Jupyter Node interface. Have you ever worked on Colab? So it gives an interface like Colab. Okay. So this I will write code here, and I don't need to think about data ingestion and other problem. I also can see my pipeline here. I also can see my AI workload, how it is training, how it is going on here on the tensor board. And if we run this, I think there will be an upcoming pipeline here. Okay, I think I need to install all of this or run all of this. So typically, what I mean to say is, working on a Qflow with SamSpark is too much easy. So that's why I love Ubuntu. So moving on, I think we don't have much of time. So moving on, so what we have done. So I teach in multiple colleges. So I work in Tribhuvan University. So on a computational physics class, it is compulsory to have an Ubuntu OS. And for teaching high performance computing in one of the colleges, Herald College, it is compulsory to have an Ubuntu Linux, because the GPU computing and the drivers that NBA gave are more stable on Ubuntu. So we typically do trainings online. If you want to join, there is an website called Advanced Material Research Lab. So on that website, we typically train the new peoples. And we also sometimes collaborate with the open source communities. So what's our future plan on the computing side? So I think we have a limited number of GPUs here in Nepal. So we'll expand our GPU cluster. We will establish an AI supercomputing center by 2030. And we will provide every Nepali researcher to work on HPC system for their AI models by 2030. So key takeaways are, if you work on Ubuntu, it's a lot easier, it's more affordable, and Ubuntu system typically helps as new researchers and old researchers equally. And Ubuntu will, I think, maybe in 3 or 4 years, take over Red Hat system. So I want to acknowledge few of the peoples who are working on the SPC community, supercomputing community. So one is Dr. Rajendra Adhikari. He was the first person to introduce supercomputing at Nepal. So he installed the KU Supercomputing Center and run it for, I think, a year. And second is from Dr. Madhav Prasad Ghimire from Tribhuvan University. So he is a supervisor of TU Supercomputing Center. And I will also want to acknowledge Umesh Upadhyay. So he is a non-profit founder of SPC Nepal, who typically train students on high-performance computer or supercomputing system. And two of my colleagues, Raj Sir and Saroj Purasaini, both are meteorologists who work on forecasting Nepal's weather on a governmental cluster. So, are there any questions? So, the simulations are a little bit messed up. So, we cannot accurately 100% say that this will happen. But if the physics are right, so it will happen. So, we predicted the flash flood early, a day early. We said that there will be drought in Tarai, but these models need to be updated. So for predicting the 3 days ahead time, for if the prediction is wrong, then again we need to add the current data to the system. So we don't have that much of power to predict a week ahead weather, but we can predict within a day. Yeah. We generally send the reports to I think disaster authority. So I think I forgot the full name of the authority, Disaster Risk Management Authority, and they will advise every governmental agencies that this will be happening soon. So the slide I was showing you here, this was a day ahead. We all warned all government agency this will be happening on this district, and generally it is coordinated by CDO office. Oh, there's a report online. You can see the weather reports and all the simulations online. So if you go to Department of Hydrology, Meteorology website, you can see all the simulations. But we do have only 3 days lead time. That means we can only predict 3 days early. So inside the DSM, we are thinking to expand our simulations to 7 days, and we are trying to work on AI workloads. So it typically, we do have a small cluster. So in future days, I think it will be available for your last models. We do have a data logger, AWS system. We own an automatic weather station. We have installed, I think, 200 of them, and the data gets from there. I think SIM card sent from the SIM card network. So are there any questions? So thank you.